Hello, so in this video we're going to be looking at the laws of exponents. So to start with, laws of exponents, we know that anything to the power of 1 is just itself. So x to the power 1 would be x. However, when we have any number to the power 0 or x to the power 0, in this case, it's always 1. Any number to the power of 0 is always 1. Any number to the power of 1 is just the number itself. So once we've got that out of the way, we can look at our first exponent law right here, where we have x to the power, let me give you an example there, x to the power 2 times x to the power 3. Now for us to find what x to the power 2 times x to the power 3 is, well, from our exponent laws, we know that when we have the same base, in this case a, in this case we have x as our similar base, we can add our exponents, which in this case is 2 and 3. Hence my base stays the same as x. I add my exponents 2 and 3. I end up with x to the power 5 as my answer. That exponent law helps us multiply exponents with the same base by adding their powers. Our second law is a to the power m divided by a to the power n is equal to a to the power m minus n. Again, we need to have the same base, and as you can see here, it says a cannot equal 0 because we cannot have our denominator 0, that's undefined. Now let's take this into an example here. Let's say x to the power of 8 divided by x to the power of 4. Well, because we have the same base, I can subtract my base of my first power, or my power in my numerator, with the power in my denominator. Hence I have x to the power 8 minus 4, which gives me x to the power 4. There we go. Now let's look at another example for division really quick here. Let's say we have x to the power negative 8 divided by x to the power positive 2. Well, we have the same base, hence I can do x to the power negative 8, and I can subtract my denominator, the base, the power of the base of my denominator. Hence I have a 2 as my exponent, hence it'll be minus 2. Now if you see, I have x to the power negative 10. Of course I cannot have a negative exponent because exponent, basically we're doing repetitive multiplication, but we can't multiply backwards. Hence we have another exponent law where when we have a negative exponent, for example a to the power negative 1 is equal to 1 over a. Let me write this here. A to the power negative 1 is equal to 1 over a to the power 1. Or we can also write that as a to the power negative n is equal to 1 over a to the power positive n. There we go. Essentially, in this case, when we have our base of x, we can reciprocate our base. Hence, we have 1 divided by x, and our our exponent for our tags along, and it becomes positive when we move it to the denominator. Hence, we can represent it as 1 over x to the power 10. Now moving to our third exponent law, a times b to the power m is equal to am times bm. Now let's bring this into an example. We have 2x to the power 4. Now when we have something like this, our a is 2 and our b is x. Hence we have to, let me just represent it as 2 times x to the power 4. Hence our power 4 applies to our 2 and to our x. Hence we have 2 to the power 4 times our 4, sorry, times our x to the power 4. Perfect. Now 2 to the power 4 we know is 16. 2 times 2 times 2 times 2. 16 times x to the power 4, which is equal to 16x to the power 4 as a result. Well, perfect. Okay. Our next exponent law, we have a divided by b to the power m is equal to am divided by bm. Again, we use our FOIL or fraction method where we have to multiply each of our variables, our denominator and our numerator. With our exponent, we have to apply it to that base of a or b. Hence, we have am divided by bm, just like our third exponent law. Now, in this case, let me take an example here. So this is our fourth exponent law. This is number 3. Fourth exponent law is a divided by b to the power m is equal to am divided by bm. To put this into perspective, we're given an example of x divided by 4 to the power 2. Now what we would do here is we would apply our exponent to both our numerator and our denominator. Hence we have x to the power 2 divided by 4 to the power 2. If we can expand this, we get x squared divided by 16. There we go. When we have a fraction multiplied to an exponent, we have to apply that exponent to both our numerator, in this case a, and our denominator b. Moving to our fifth exponent law, we have a to the power m times n is equal to a to the power mn. So in this exponent law, we multiply our exponent of the base a, which is m, with our major exponent or exponent of our a to the power n, which is n. Let me put this into perspective, it'll be a lot better. We're given 2 to the power negative 4 times positive 2. Let me remove this negative here. Positive 4. Now as a result, with our exponent laws, we know that we can multiply our exponents, which are 4 and 2. Hence we have 2 to the power 4 times 2, which is 8. Pretty straightforward. And now we have 256. Now in the case if we have let's say 2 to the power 4, same thing. If you have all of that to the power of negative 2, 2 to the power 4, all of this to the power of negative 2, we can do the same thing. We can go ahead and multiply our exponents together. 4 times negative 2, hence we have 2 to the power negative 8, which now with our law, or with our exponent law, a to the power negative n is equal to 1 over a to the power n. Can apply that here. So I have 1 over 2 to the power 8, which is equal to 1 over 256. There we go. So that was the exponent laws. Hope this helps.